Well, here we are again. We got 1.6 to do today. So 1.6 is all about scientific notation. This should be review from ninth grade science at least. Maybe even did a little bit of this in middle school. But basically, some of the numbers that we use in science are way too big or way too small. And we don't want to spend a whole bunch of time writing a whole bunch of zeros. So they made this shortcut basically so that you don't have to. So well, maybe there's a better example on the next slide. Here's one. So this times 10 to the fourth basically means that we need to add a bunch of zeros somewhere. And instead of worrying about zeros, it's about moving the decimal place. So in general, if you have a positive exponent, this number should get bigger. So 6.2, the final number when we take it out of scientific notation should be larger than 6.2. If it's negative, it'll be less than. So I didn't mean to do that. If it's negative, it'll be less than this number. So since it's negative 2, this should be less than 0.15. Sorry, 1.5. So we move the decimal to the right 4 times for this first one. This is how many places we move the decimal. For this one, we're going to move it 2 times, but in the other way. So if I start at 6.2, I need to move it 1, 2, 3, 4 times. So that means I add 3 zeros. So this is 62,000. Since this is negative, I need to make the number smaller. So I move it to the left 2 times. So there's a decimal there, which means I need a 0 in front and a 0 behind it. So this is 0.015. How to put numbers into scientific notation. It's the same thing. First, you put a dot between the first non-zero number and the rest of it. So this dot will be here. Great. So then it's 8.5 times 10 to the power of however far I move the decimal. 1, 2, 3. Moved it 3 places. This one, same thing. So we find the first non-zero number. There's going to be a dot there. So this is 3.03. And then however far I move the decimal, 1, 2, 3, 4. But since it's, oops, I forgot the times 10. But since it's smaller than the scientific notation number, the exponent needs to be negative. So our number written in long form is smaller than the number in scientific notation, so the exponent needs to be negative. Okay, these should be in your packet, so go ahead and try those. Oh, no, this is whether they're correct or not. Excuse me. So they're correct if there's one number outside the decimal. That's really all there needs to be, one non-zero number. One non-zero number outside the decimal. So that's a 9, so this one works. This one doesn't work because there's a 0 to start it. They should have started it with the 4. This one does not work because there's not a times 10 here. You don't times it by any number. It always has to be times 10 to the power of something. This one does not work because there's supposed to be a decimal there. This one looks good. That's a yes. I did y's and n's instead of i's and c's, but you can figure that out. Okay. Don't need to do that. You just use your calculator. And then there should be a mini worksheet posted on Schoology at some point. So that's it, short and sweet, and mostly review.